Hey everybody, this is Mr. Bells here. This video is just a separate one for something called the difference quotient. The difference quotient allows us to find a line tangent to a parabola at a given point. So here's our parabola, x squared plus 6x minus 5, and here's the point, x equals -4, and it's a lot of work, but again, here's our goal, x squared plus 6x minus 5. That's a parabola that opens up, so we got something like this. Let's say -4 is right over here. So we're going to find the equation of this line that's tangent to that point using this big ol' honkin' scary formula. Okay? So the first thing that I'm going to do is I'm going to find out what this actual point is. Well, I know that the x value is -4, so I'm going to go ahead and take -4 and I'll plug it in to the quadratic and find out its corresponding point. So -4 squared is 16. 16 plus -24 is -8. -8 minus 5 is -13. Okay, so my point right here is going to be -4, -13. That is the point on the parabola. Now, how does this whole thing work? So what we're trying to do is we're going to try and find another point that's like so close to this point right here, so that those two points are going to be just in a fraction apart, right? Because if I use this point and this point, would you agree that's kind of close to that line, but it's not really close to that line? So if I make them a little closer, that's kind of close to that line, but it's really not that line. What I'm trying to do is use this point and a point so close to it that you can barely even tell that it's there to represent that line. Okay? So this is really just kind of using this like the slope formula. So here's how it works. I need to take the function of x, which would be x squared plus 6x minus 5, and I need to add a tiny little smidge to it. So just go a tiny little bit away. We're going to call that amount h. Again, think billionth of an inch away. And then I'm going to subtract the value of f of x and divide it by the actual distance that I met. So basically y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where the x change is just that little amount h. But the algebra is pretty big. So here we go. So f of x plus h means that I've got x plus, let me use this, x plus h squared plus 6 times x plus h. See where I'm shoving x plus h into both of these things? Minus 5. And then minus the entire function itself, x squared, f of x, right? X squared plus 6x minus 5. And remember, this thing right here is going to find me the slope of this line. It's not going to find me the equation. I got to get the slope first. And this is all over h as h heads towards 0. So h gets so small, so tiny, that it's almost indecipherable. Like I said, like a billionth of an inch away. So here's what I got to do first. I got this x plus h squared, which is x squared plus 2xh plus h squared plus 6x plus 6h minus 5 minus x squared minus 6x plus 5. All I did was do x plus h times x plus h, which is this. I distributed the 6 into those sets of parentheses, 6x plus 6h. Copy the minus 5 down. And then I had to subtract this entire function, so I have a minus x squared, I shove in the minus through, minus 6x, and minus a -5 means plus 5. So I got this whole thing over h as h approaches 0. So far, so good. So you're going to know at this point right now that this big scary expression here is actually going to simplify down. You can see some things that happen to be true, like this right here. This 6x and this -6x. This negative x squared and this x squared, and this 5 and this negative 5 all should cancel themselves out. And the only things that you should be left with are terms with h's in them. Isn't that crazy? So you get 2xh plus h squared plus 6h over h as h approaches 0. And again, you know you can't let h equal 0 because then you'd have division by 0, and that's undefined, and we'd have a function that doesn't work at all. So what do I do next? I'm going to go ahead and factor the h out. Factor the h out of this thing. Factor it like a dentist. So I got h times 2x plus h plus 6, right? Over h as h approaches 0. I got that thing right there. And you can see I'm getting closer. I'm getting closer on this stuff. So then this h can kill this h because they're the same size, right? And then I have 2x plus h plus 6 as h approaches 0. So tiny, so tiny. Guess what happens to this h? Since it's so inconceivably small, it really doesn't matter at this point. So my slope equation is 2x plus 6. Isn't that cool? That means that any value that I choose to pick, and I chose -4, to find the slope of this line over here at -4, all I have to do is plug that -4 into this slope equation, and I'll get the slope at that point. And this slope works for anything that I plug in on this entire parabola. Pretty amazing. So I'll go ahead and plug -4 in, and when I do that, 2 times -4 plus 6, 2 times -4 is -8, -8 plus 6 is -2. So my slope is -2 at that point. Slope is -2 at that point. And again, you can see if I plug in different values, those slopes of the lines are going to keep changing. Okay, but I wanted it -4, -13. So now I'm going to go ahead and do point slope form. So I get y plus 13 equals -2 times x plus 4. Isn't that kind of nice? Just you can use the -4 and the -13. Y minus -13 becomes plus 13 equals -2 times x minus the x value, which minus -4. Okay, so then I'm going to go ahead and put it all the way in. So y plus 13 equals -2x minus 8 minus 13 minus 13 y equals -2x minus 25. So it's my belief that the equation to this line right here that's tangent to this parabola right here at this point, -4, -13, is this. Desmos is a really quick and easy fix for this, but we're going to go ahead and use our handy dandy graphing calculator. This will be the last thing on this. Make sure you can do this. This will definitely be on your test too. I'm going to zoom this in really close. Focus for you. Oh, that's awesome, right? So I'm going to get rid of all these things. These are all old stuff from the last one. I'm going to leave the plot on. I'm going to go ahead and put this point in so that we can see it. So this was -4, -13, -4, enter, -13, enter. Go to my y equals, put in my original parabola, and it's going to suck if this isn't right. Plus 6x minus 5, enter like that, and then -2x minus 25. But I'm going to save that for just a second. I want you to be able to see this first. So I'm going to hit graph. There's my parabola. Kind of what I thought it was going to do, right? Way down there. I don't want to be able to see it. So I'm going to make my y min much lower. So I'm going to put that down to -30. And now you can see, oh, look at that. My point's on my parabola, so I'm feeling pretty good about this. And now if I put in my line, -2x minus 25, enter in graph. Uh-oh, What the heck? Mr. Bells can't do basic addition. That's what happens when you do this late. A negative 13 and a negative 8 is not a negative 25. And some of you are probably already ready to email me on that one. That is a negative 21. A negative 21. Can you believe it? Look at that. I did, 75 computations up to that point, and my screw up was negative 8, negative 13. Ha, you're right. I did do that one on purpose. Because I want you to be able to check with your graphing calculators and have things make sense. And this is obviously not touching that point. And it's very easy to make a mess like that, but I can always catch it if I check to see if things make sense. And this one right here, unfortunately, doesn't get caught unless I actually graph it to check to see if it works. So let's go ahead and make this negative 2x minus 21. And now watch. Look at that. Dead on perfect. And this is a process called the difference quotient. Finding the equation of a line tangent to parabola at a given point. One more time. How does this work out? This formula we use every single time. What's the process? The process is, given any point on the parabola, we try and find a point that's so close to it that the x value change right here, we're going to call h, is so small that it's almost insignificant. And then we can find the slope between those 2 points like that. And that slope we can use for all of them. And once we find this slope formula, this one right here, again, this works for any points along the parabola. We just plug that x value into it, and it will tell us that. That's what's really cool about this. It is a long process, but hey, this is pre-calc, everybody. It should be a little bit more work at times. Okay, we will talk to you later. Hope this was a good example. Make sure you practice this one a lot. Talk to you later.